Okay, let's turn next to a product development application. And let's first discuss the problem as a narrative, which we know is not ideal because we want to structure and visualize the problem. But imagine there's a car producer that needs an engine for a new car. And the car producer can either start with research on engine development and, if successful, continue with research on engine fabrication. That's decision A. It could also start with research on engine fabrication and, if successful, continue with engine development. That's decision B. Or the company can do the research and engine fabrication development simultaneously. That's decision C. Or it can neither conduct research on engine development and fabrication and just buy the engine from another supplier. Okay, so now let's take a look at some cost. So decision A or B was associated with the sequential development of the engine, which is development and fabrication. And if things go really well, meaning if both research efforts succeed, the company can produce each engine at the price of 9 or at the cost of 9. But if the first research effort fails, which might be either the development research or the fabrication, then it still can buy the engine at a cost of 24 from a third supplier. But if first research succeeds, either development or fabrication, but then the second fails, then the company needs to buy the engine at 34. And for decision C, so that was the case when the company simultaneously develops or does research on development and fabrication. And again, if that is successful, then they can produce the engine at a cost of 9. But if that process fails, they also have to buy the engine at the price of 24. And decision D would be just to forego any research on development and fabrication and just buy from a third-party supplier. So the firm needs 10,000 engines, and the probabilities are now shown in the decision tree. So we need to fill that out with the information just given. So we can see here the probabilities, and we have decision tree A, so they start with development. And I'll just write it down. So that causes cost of 50,000. Okay, if that fails, then we have to buy the engine at 24 from a third-party supplier. So then we have to buy the 10,000 engines at the price of 24. So that's 240,000, but plus the 50,000 in development that we invested. So here we would then get a payoff of 290,000. But if the development is successful and the fabrication is also successful, well, then we can produce the engine at at the cost of 9, so that's 90,000. But we also had 80,000 in development because the fabrication that cost another 30,000. So 80,000 plus 90,000, that's 170,000. Okay, but if the development process is successful, but the fabrication process fails, well then that's the worst case scenario, because then we invested already the $80,000 in vain, And now we have to buy the engine at $34 per unit. So that's 340 plus 80, that's 420,000. Okay, so now let's move to B. So now we start with the fabrication, and that causes costs of 30,000. If it is successful, that's great. And then we have to move to development, which causes another 50,000. Maybe I can put that underneath so we don't forget it. So it's also 80,000 in total. And if it is successful, well, that's the same as here in the first, in decision A, if everything goes well, 170,000. So we spent 80,000 on research, and if everything is successful, we can produce the engine at 9. 10,000 times 9, 90,000 plus 80,000, that's 170. And likewise, if things go bad, you know, it's just another 420,000. We have to buy the engine at the cost of 34, so that's the worst case scenario, 420,000. And again, if we first fabricate, but then things fail, then we buy it for $20 an engine, so that's 240, and then we have the 30,000, which is the 270, so we get 270,000 here. So if development and fabrication is successful, then we spend 80,000, that's together 80,000. And then we can produce the machine at $9 each, so that's 90,000. So here we also will get 170,000. But if things fail, while doing development and fabrication research simultaneously, we lost the 8,000 and we have to buy the 10,000 engines for 24 each. 240 plus 80, that's 320. And if we need to develop or fabricate, we can buy everything for $25 each, so that's 240,000. And the probabilities are given. So that was already the hardest part. So now on the next slide you see again the results. And what we need to do now is we just need to evaluate each individual decision. So let's start with A. So the expected costs, A's expected cost. So it's here in that little yellow box in the down right. So now we just say, okay, we develop A. There is a 0.9 probability that we get with probability 0.8, 170, and with probability 0.2, 420. But there's also a 1% chance that development fails, so plus 0.1 times 290. So for A, we get 227. So this is pretty straightforward. So now let's move to B's expected payoff. So B, we have 0.8, and then in parentheses, the 0.9 times 170, plus the 0.1 times the 420, plus the 0.2 times the 270, and there's actually a typo. And then, let me quickly double check that one. So then we would have first 0.8 times, open parentheses, 0.9 times 170, 123, plus 0.1 times 420, 1, 2, 3, close parentheses, plus 0.2 times, so now with the corrected value, 270, 1, 2, 3, equals 210. Yeah, so that was a typo. So the result is correct. So B is already better than A. So what about the expected cost of C? So the probability that development and fabrication is simultaneously a success is 0.72. So then we do 0.72 times 170,000 plus 0.28 times 320,000, and there's no need for it. That should be 212. Let's double check again. So 0.72 times, so I enter it into my calculator right now, plus 0.28 times 320, 1, 2, 3, 212. So that's also correct. Okay, so B is still the best so far. Let's take a look at the final one, and of course D is just 240,000. So now we can compare all decisions. A was 227, B was 210, C was 212, and D was 240. So the optimum decision is B. Okay, so the hard part here was really to fill out the expected payoffs, but once we have succeeded in doing that, it's pretty straightforward. Okay, let's stop here, and then let's move to a market research problem.